12,800 years ago, there was an ordinary morning in North Africa. Water flowed through stone channels built with slopes calculated to the precise centimeter. Tree roots spread for dozens of kilometers beneath the ground, drawing water from an artificial irrigation system stretching across the entire region. Stone roads connected settlements to one another, laid using a dry stone interlocking technique that modern engineers still acknowledge as remarkably sophisticated. It was an ordinary morning. Then everything ended. No one survived to tell the story. No written record was left behind. No oral tradition passed down intact enough to reach us today. Only the Earth still remembers. And the Earth has been telling that story in a language we have not been willing to read. Because if the Earth is right, then everything we think we know about the history of human civilization needs to be rewritten from the beginning. The Sahara today is 9 million square kilometers of sand and rock. We have seriously excavated and studied less than 1% of that area. And yet, within that 1%, we have already found enough to make a great many people deeply uncomfortable. Today we are going to go through it piece by piece. Every discovery, every finding that was blocked, reclassified, or buried a second time beneath layers of administrative paperwork and suddenly canceled budgets. And by the end, you will find yourself asking a question that has no comfortable answer. Are we simply unaware of what lies beneath the Sahara? Or have we made a quiet, collective choice not to know? Before we talk about what was buried, we need to talk about what once existed here. Mainstream geology admits one thing openly: the Sahara was not always a desert. Between roughly 11,000 and 5,000 years ago, this region was green and humid, dotted with lakes and threaded by rivers. Herds of animals moved across landscapes that today are nothing but dunes. Scientists call this period the African humid period, a neat chapter in geological history with a clearly defined beginning and a clearly defined end. But the timeline they give us has a serious problem that very few people stop to question. In 1981, a French geological survey team was drilling for water sources in southern Algeria when their drill bit stopped abruptly at a depth of about 127 feet. Not because of hard rock, not because of equipment failure. The drill had struck wood, petrified wood, lying horizontally inside the earth in a region that, according to the official historical record, should have been barren desert for tens of thousands of years. They kept drilling. At around 200 feet, they encountered a second layer of petrified wood. At 340 feet, a third. Each layer was horizontal, parallel to the others, and spaced at intervals that felt unsettlingly consistent. Then they ran ground-penetrating radar scans along the horizontal plane. The wood signature extended continuously for 43 miles, arranged in a pattern that was nearly a perfect rectangular grid. 43 miles in a rectangle. This is the point that matters. Natural forests do not grow in rectangles. Trees follow terrain, water sources, and wind patterns. A natural forest produces irregular, organic shapes with no right angles and no evenly spaced rows. A rectangle is the product of planning, and planning is the product of human intelligence. The survey team sent their results back to Paris. Carbon dating of the petrified wood returned ages between 14,000 and 17,000 years old. That placed living, thriving, large-scale vegetation in a region that, according to accepted chronology, should still have been struggling through the tail end of the last ice age, in conditions far too harsh for vegetation at that scale. The findings were published in a French geological journal in 1983, discussed briefly in academic circles, and then quietly absorbed into what researchers sometimes call the footnote abyss, that place where inconvenient discoveries go to exist without being remembered. But this discovery was not standing alone, and this is where the story truly begins. In 2003, a German-led expedition was working in northern Chad. At a depth of roughly 180 feet, their ground-penetrating radar detected what their report described as an interwoven network of petrified wood covering an area of approximately 12 square miles. The structure of this network resembled the foundation of an enormous construction, with intersecting lines running in fixed directions. The radar suggested the network extended significantly deeper, but funding was cut before the team could verify its full extent. A geologist on the expedition, speaking anonymously afterward, said the government officials had told them directly, "If you keep digging, you will find walls. And if you find walls, you will have to explain what those walls are doing here. And nobody wants to be standing in front of that question." In 2006, a team of Italian archaeologists working in southern Libya stumbled across what looked like a Roman road. Straight, stone-paved, running for several miles before disappearing under the dunes. They excavated a section to determine its age. It was not Roman. Organic material trapped inside the road returned carbon dates of between 9,000 and 11,000 years old. Before ancient Egypt, before Sumer, before every civilization we have been taught represents the beginning of human history. And the road had not been built by simply stacking rocks. The stones were locked together using a jointing method that modern engineers immediately recognize as deliberate load-bearing design. Whoever built this road understood physics and materials. They built it to last for a very long time in a land that, at the time of its construction, had not yet become a desert. The Italian team wanted to follow the road to see where it led. Funding ran out. The site was backfilled. The results were published in a regional archaeology journal that almost nobody reads. A road leading somewhere, and we chose not to follow it. In the same period, researchers began paying closer attention to the Richat structure in Mauritania, also known as the Eye of the Sahara. This is an enormous concentric formation roughly 30 miles in diameter, clearly visible from space, with rings so mathematically precise they look almost engineered. The mainstream explanation is that it is an eroded geological dome, shaped over millions of years into concentric circles by natural weathering. That sounds reasonable, until you notice that those circles match Plato's description of Atlantis with striking accuracy, including the alternating bands of land and water arranged at specific proportional distances. Officially, that is dismissed as coincidence. But what makes the Richat structure genuinely significant is not its surface shape. It is what lies beneath. Radar and magnetometer surveys of the area have revealed the same kinds of signals researchers found in Algeria, in Chad, and in Libya. Fossilized organic networks, rectangular voids suggesting rooms or corridors, magnetic signatures inconsistent with natural rock formation. And in 2018, a satellite archaeology team from the University of West Alabama identified more than 300 potential structural foundations within a 15-mile radius of the structure's center. Foundations imply buildings. Buildings imply a city. And a city of that scale would have required water, agriculture, and infrastructure to sustain it, all in a region that is now one of the most uninhabitable places on the surface of the earth. Are you beginning to see the shape of something? Let us be more specific about what we mean when we talk about infrastructure. In 1977, a Soviet geological team working in the Libyan desert found what their report called a gallery, an underground chamber approximately 800 feet long and 60 feet wide. The walls were coated in sandstone that had been fused into a glass-like surface, not carved, not smoothed, fused, by temperatures high enough to bring stone to a near-liquid state, and then let it solidify again. Running through the center of this gallery was a water channel, perfectly straight, sloping at a precisely calculated grade to direct water flow in a specific direction. Along the walls were petrified root impressions embedded in the fused stone, indicating that plants had been growing here while the channel was still in active use. The Soviet team used seismic equipment to trace that channel. It extended for more than 20 miles, connecting to other chambers, other channels, other voids that together formed what appeared to be a large-scale underground irrigation system. The report was classified in 1979. After the Soviet Union collapsed in 1991, several Russian researchers attempted to revisit the site. The coordinates listed in various reports did not match each other. Satellite imagery of the area showed nothing but sand. When a French team applied for excavation permits in 1998, the Libyan government denied them without explanation. That gallery, if it exists, is still down there somewhere beneath the Libyan desert, with its channel, its fused stone walls, and its root impressions, waiting. In 2011, a solar energy company was preparing a site for panel installation in Morocco when their excavator, at a depth of about 43 feet, pulled up an object more than 4 feet long. Not rough earthenware, not crude pottery, glazed ceramic, fired at high temperature, with a material composition consistent with advanced kiln technology. The inside showed residue from water transport. The outside showed weathering patterns, consistent with having been buried under immense pressure for a very long time. This was a section of engineered water pipe, complete, with clear evidence of use. The company reported the find to the Moroccan Ministry of Culture as required by law. 3 days later, an assessment team arrived. The site was filled in. The ceramic piece was confiscated. The official report described it as pottery shards of indeterminate origin. A 4-foot section of engineered water pipe, complete and intact, with clear evidence of use, was reclassified as pottery shards. One of the excavation workers photographed the piece before it was taken. That photograph circulated on archaeology forums for about 6 months before the sites hosting it received legal takedown notices. But before it disappeared, researchers had already noticed something important. The exterior weathering patterns indicated the object had been buried under significant pressure for an extremely long period of time. When you place all of this together, the 43-mile route network in Algeria, the underground irrigation gallery in Libya, the ceramic pipe in Morocco, the 11,000-year-old road in southern Libya, a picture begins to take shape. Not of a primitive civilization just learning to farm, but of a civilization that had mastered the management of water across continental distances, that cultivated trees systematically over enormous areas, and that built infrastructure designed to endure. And all of it ended in an extremely short period of time. This is the simplest, clearest, and hardest to dismiss piece of geological evidence in this entire story. Anywhere across North Africa, if you drill down and collect sediment cores, you will find the same thing. Below a certain depth, rich organic soil, pollen from dozens of plant species, microbial evidence of a thriving living environment, signs of abundant water and life. Above that same depth, mineral-heavy sand and silt, the kind of sediment you find in the aftermath of a large, fast-moving flood. And the boundary between those two layers is not a gradual transition zone hundreds of meters thick. It is a sharp, clean line consistent at the same depth across the entire North African continent. Think about what that means. If the Sahara transitioned from green to desert over 6,000 years, as the mainstream account says, that process would leave behind hundreds of meters of transitional layers in the sediment record. You would see soil gradually drying, vegetation slowly thinning, mineral composition shifting over time. That is what 6,000 years of any natural process produces. A sharp line can only appear when change happens within a very short window of time, not thousands of years, not hundreds of years, possibly months. Geologists call these sharp transitions unconformities, and they typically describe them as representing millions of years of missing geological record. But when you find the same unconformity across an entire continent, at the same depth with the same sediment composition, the millions of years explanation starts to feel less like science and more like a way to avoid asking what could have caused simultaneous catastrophe at that scale. Dr. Robert Schoch, the Boston University geologist known for his work demonstrating that the Sphinx was eroded by rainfall and is therefore thousands of years older than mainstream Egyptology, accepts examined core samples from the Algerian site in the early 2000s. His conclusions were rejected by mainstream scientific journals. They were eventually published in an independent archaeology journal, and they read as follows. The petrification process observed in these samples is consistent with conditions involving both extreme heat and simultaneous mineral saturation. This suggests a singular high-energy event rather than gradual geological processes. A singular high-energy event, translated into plain language. Something very large happened very fast, and it buried everything nearly instantly. The question is what? Mainstream science actually has a name for that event. They call it the Younger Dryas. Around 12,800 years ago, within the span of just a few decades, global temperatures dropped sharply. Glaciers that had been retreating began advancing again. Dozens of large animal species went extinct nearly simultaneously across multiple continents. The Clovis culture in North America, which had been flourishing, vanished from the archaeological record with almost no transition period. For many decades, the cause of the Younger Dryas was one of the great unsolved mysteries of geology. Then, beginning in the early 2000s, evidence began accumulating for a very specific hypothesis. In sediment layers dated to 12,800 years ago, found at sites across North America, Europe, and Western Asia, scientists discovered nanodiamonds, a form of carbon that only forms under the extreme pressures generated by cosmic impacts. They found elevated levels of iridium, an element that is rare on Earth but common in meteorites. They found millions of tiny glass spherules created when rock and soil were melted at temperatures no natural surface process can generate. And they found evidence of massive simultaneous fires across multiple continents, preserved as a thin layer of black carbon in the global sediment record. All of these markers appear at the same depth, at the same moment in time, around the world. The Younger Dryas impact hypothesis proposes that a fragment of a comet or asteroid broke apart in the atmosphere or struck the northern ice sheets, releasing an enormous amount of energy and triggering the rapid melting of vast quantities of glacial ice in an extremely short time frame. The hypothesis remains contested within the scientific community, but supporting evidence grows with each passing year. Now place North Africa inside that picture. When billions of tons of glacial ice melt suddenly at northern latitudes, that water does not disappear. It flows downhill, following valleys and natural drainage basins southward and westward. A significant portion of it would have moved across North Africa, carrying with it enormous quantities of mud, soil, rock, and debris. When that surge arrived, it would have covered everything in its path. Buildings, roads, trees, people. When the water finally receded, drawn into the ground or evaporated as the climate rapidly shifted, it left behind a thick layer of sediment. That sediment dried. Wind drove sand across it. Within a few hundred years, there was no surface trace of anything that had existed below, except for what had been buried quickly enough and deeply enough to fossilize rather than decay, like the 43-mile route network in Algeria, like the underground irrigation gallery in Libya, like the 11,000-year-old stone road in southern Libya, like the ceramic water pipe in Morocco. This is the mechanism that explains why the boundary layer beneath North Africa is sharp rather than gradual. It explains why the petrified wood in Algeria is preserved far too well for slow natural mineralization to account for. And it explains why we keep finding the infrastructure of an advanced civilization lying perfectly intact beneath tens of meters of sand, as though it was buried before it ever had time to fall apart. Now we arrive at the hardest question. If the evidence is there, if ground-penetrating radar can detect it, if satellite archaeology can image it, if every time someone accidentally digs deep enough they find something that does not belong in the accepted story, then why do we still know so little? The answer is not a single coordinated global conspiracy controlled by one unseen hand. The answer is simpler, quieter, and in many ways more troubling than that. It is the inertia of a system that has decided what it already knows. In 2015, A team from the University of Leicester used satellite data to identify more than 500 potential archaeological sites across a 30,000 square kilometer area in Sudan. Among these, 37 sites showed depth signatures indicating buried structures at between 100 and 300 feet down, with dimensions consistent with large public buildings. The team applied for excavation permits. They were denied. The official reason: insufficient infrastructure to support a dig of that scale. The real reason, according to a team member speaking off the record: nobody wants to find a city older than Egypt in Sudan because it breaks too many things. Too many things. That is the polite way of saying it would require rewriting textbooks, acknowledging that major academic institutions have been fundamentally wrong about foundational questions, and withdrawing funding from researchers who have built entire careers on the current narrative. Nobody needs to issue an order. The system does it on its own, through thousands of individual decisions made by thousands of individual people, each with their own perfectly reasonable-sounding justification for not asking the question one level deeper. Funding is cut before the dig goes deep enough. Results are published in journals nobody reads. Objects are reclassified as something less interesting. Sites are backfilled for safety reasons. Permits are denied on administrative grounds. Nobody is lying. Everyone is simply choosing the easier path. And the easier path leads to a Sahara that remains an endless, empty desert, just as it has always been described, containing nothing that challenges what we have already decided is true. But the earth does not care about those decisions. The earth only holds what it holds. And every year, erosion reveals a little more. Wind shifts the dunes and exposes a section of a wall. Flash floods wash away sediment and uncover tools, ceramics, fragments of something we do not yet have the right name for. The Sahara covers 9 million square kilometers. We have seriously studied less than 1% of it. Within that 1%, we have found enough to make people deeply uncomfortable. 99% remains untouched. Let us return to that last morning. Someone was checking the water channel. Someone was walking along the stone road. Someone was looking up at a northern sky and seeing something that did not look like any morning they had ever seen before: a streak of light, a cloud with a shape that had no name, something that arrived with no warning and no precedent. We do not know whether they understood what was coming. We do not know whether anyone survived and tried to pass the memory forward. We do not know whether the flood myths found in nearly every culture on Earth carry some faint echo of that morning buried inside them. What we know is that 12,800 years later, we are still trying to find them beneath 9 million square kilometers of sand. And what we have already found cannot be explained away. A 43-mile rectangular root network is not a product of nature. A razor-sharp boundary layer between living soil and dead sand is not the result of 6,000 years of gradual change. An underground water gallery with heat-fused walls is not the work of primitive people. An 11,000-year-old road built with sophisticated load-bearing joinery is not the achievement of hunter-gatherers just learning to shape stone. And a 4-foot section of glazed ceramic water pipe is not pottery shards. Someone was here. Someone built. Someone managed water and cultivated forests on a scale we cannot yet fully measure, because we have only seen less than 1% of what lies below. The question is not whether they existed. The question is what we are waiting for before we go looking for them. Or perhaps we already know the answer to that question too, and we are simply not yet ready to face what finding them would mean.